plateau. So good afternoon once again, everybody outside from dialing in from Southeast Asia Pacific, and good morning, everybody who dialed in from Europe. We're happy to have you here, and thanks for joining in our today's webinar, Management of Endotoxins and Mycotoxins in Poultry Operations, which we have set up together with our channel partners, Nature Care from Bangladesh, Kantipur from Nepal, and Vet Care from Sri Lanka. I am your moderator today. My name is Klaas Krüger, and I'm team lead in the global animal nutrition company EW Nutrition. I'm working in this company now since 2004, since the very beginning. I had a short break of 8 years where I left this company looking for some other experiences and came back in 2017. With me together online are two presenters, Professor Johanna Fink-Gremmels, you can see her in the video, and Dr. Claudio Campanelli, as well as our panelist, Dr. Mahindra, who should also be visible in the camera. I will give some background to Johanna and to Claudio, starting with their presentations, but Dr. Mahindra, I would like to already introduce by now. He has completed the Bachelor of Veterinary Science and Animal Health and did his post-graduation in Master Veterinary Science at the University at Mumbai. He has a technical orientation with a professional experience, professional life, working since almost 30 years in the poultry breeding, hatchery, and feed milling and laboratory background. So we are very happy, Dr. Mahindra, to have you here. You will accompany us today as a panelist during the question and answer sessions all over the webinar. Just a few technical points I would like to explain before starting this webinar. We will have 3 comprehensive presentations, which will last at least 60 minutes. During these presentations, you can ask questions within this question and answer box. You can have this in written. We will read during this webinar these questions, try to answer them online as soon as possible. If they are more complex, we will take them to the end of this webinar and answer them verbally. In case we cannot answer any questions because of time, we are very happy to come back to you personally to answer these questions then by email. At the end of this presentation, I would close with a short poll, which is a question series where we would like to get your feedback to this webinar. So once again, thanks for being here. And now I have the pleasure to start this webinar with a short company presentation to EW Nutrition. I will highlight most important points which are important for you, our customers and prospects. So Claudio, please go to the next slide. We're waiting for the slide to change. So I don't want to bother you too long with a company introduction, but some slides I would really like to highlight to explain to all of you. And starting a company presentation should not starting with the words about the company, but starting with the most critical industry challenges we see from our prospects and customers. And we have identified some of these and written down on this slide. So if we talk about health and welfare of animals and humans, I think this is a very critical challenge we see all over the world, all over our customers. We all are part of the food chain, and so we identified this challenge as very important, where we will dedicate time and solutions on. Second bullet point, lower antibiotic use. You will see in my next slide, we even base our mission on this bullet point, which is very, very important globally. And we will talk about this next slide. Talking about profitability and production efficiency, the third and the fifth bullet point. I don't think I need to explain too much about this. We have to work in a profitable way to sustain our business over years. This is the challenge our customers have, and this is our dedication offering solutions. And the fourth bullet point, I'm very happy to have this whole webinar now about this. Harmful substances reduction is a challenge we see in each and every single region. Today we spent 60 minutes on this bullet point. As said, we have a mission. Now waiting for the slide to change. We have a mission as a company, which is our purpose, which is the reason why we wake up every morning. Where this is the mission where we spend most of our time. All our efforts are mainly linked to this mission, and this is mitigating the impact of antimicrobial resistance by providing comprehensive animal nutrition solutions. This sounds very broad, but everybody knows that AMR, antimicrobial resistances, is a threat, is a challenge we see globally, and we as EW Nutrition will have solutions for this mission. And you can see in our next slide what does mean comprehensive and what does it mean to work with a global company. First, before going to the family, I would like to address our core values. Every time we get in contact with the outside, we believe customer first is the main value we should have as a company. That means that each and every single region director outside and regional technical managers, sales guys have as much power as possible in the region to really dedicate their time fully to our customers. We take the time to learn about customer specifics. We dedicate time to develop customer specific solutions. Again, I said in the slide before, it is comprehensive. What does comprehensive mean? How can we offer these solutions? I would like to show in our overview slide about the company. We as EW Nutrition are member of a family of leading agribusinesses. Some of you have already heard the name EW Group. It is a name, a family Erich Wessjon, which is in the background. But most of the companies being active globally, you will have already heard. I will start in the corner down left, where we have food production. This is very regional business where we produce, for instance, mushrooms. Here in Germany and even Europe, we are market leader in this segment. This is still a regional business. If you go to the bottom on the right side, we will show you the animal breeding part EW Group is working in. And all these names, which I will now name, will sound familiar to you, dear customers outside. This is Aviagene, where we cover the broiler genetics, and I believe that we have a market share which is quite significant in the industry. Lohmann Tierzucht, Highline, and H&N are breeds which you will also know in all the world, in the regions, for layer business. So if we go upstairs, one in the corner on the right top, we say animal health. Here we have our sister company Vaccinova, which is working with us in the same family, producing vaccines. Meanwhile, they are also with a global footprint by having bought other vaccine companies. And on the top, on the left side, you will find our Activo picture, which is our phytomolecule-based product, and animal nutrition as a slogan. This is EW Nutrition, and the whole picture shows that we, as member of the EW Group family, can get insights of the industry. If we talk about AMR, if we talk about mycotoxins, if we talk all about the industry challenges, we have sister companies which are in the same business as we are in the food chain, and we can develop comprehensive solutions for our customer with a clear support of our sister companies. I think this is very unique, and which allows us to really say we offer comprehensive solutions. Next slide, please. Having shown this company overview, EW Group, which is a global company, also we as EW Nutrition, though being found in 2004, still very young, we are proud to show you here our commercial footprint, which is meanwhile global. And you can see with our own personnel or with a close cooperation with distributors, we cover 92% of the global feed market. Also here in the next slide, we show our global footprint from the production point of view. We see here with the blue highlighted countries where we already have areas. In the US, we have 1 production plant. In Brazil, we have meanwhile 2 production plants. In Germany, we have 3 production plants. In China and Japan, both we have 1 plant, and 1 in the area of India, Sri Lanka, Nepal is thought to be set up short term. So this is very important to serve our value of customer first. If we want to serve a value of customer first, we need to be regional. We need to be regional with personnel. We need to be regional with production. And dedicating our solutions from global to the region means that we also have to have research and development. In the middle, you see Germany, our Cologne lab with more than 30 PhD is dedicating most of its time about solutions, taking care about solutions about antibiotic resistances and enzyme production. Here we clearly go into the research part together with our sister company in Leuna, and the development part takes place in Japan on the one side, in our production plant, and in Brazil. So here we can say that our solutions which are developed will get regionalized so that we can always have solutions which will serve the customers locally. At the end, we can clearly say that we are local basic manufacturer for all the products we have. This was a kind of run-through presentation, a company presentation. I was asked not to take too much time. I hope it was of value for everybody to get an overview. Why are we living? Why are we working in this field? What are we doing? And now getting to our challenges, which I said, harmful substances. We dedicate this webinar today to poultry, talking about endotoxins and mycotoxins. And I would like to start this presentation now with Professor Dr. Johanna Fink-Gremmels. Some words I have to read now because she has a very long experience in this field, and I want to make it very clear. She was trained as a veterinarian, and already in her postdoc period, she was interested in the hepatotoxicity of aflatoxins. Sorry, very complicated words. Along with her professional career as board of certified specialist in veterinary pharmacology and toxicology, and a full professor at Utrecht University, she focused very much on food and feed contamination and food and feed safety. This topic included, of course, mycotoxins and bacterial toxins and their detrimental effects on animal health and productivity. Professor Dr. Johanna Fink-Gremmels is author of more than 300 well-cited scientific articles and book chapters, but still enjoys the practical field work and teaching activities. So thanks for being here, Johanna. You are the presenter of our first presentation. Claudia will start now to share. Please, Johanna, go ahead.
Okay, good afternoon, everybody. It's a great pleasure to be with you today, even if we cannot be there in your country, but at least we have this possibility on webinar on the computer, and I hope you can all see my slides. In the background, you see the skyline of our university, at least part of it. The topic of today is undesirable substances in animal feeds. That is a very, very broad topic. And if you go from the left-hand side, we have environmental pollutants like heavy metals, dioxins, pesticides that are of concern in animal feeds. We have, of course, the toxic plants and their metabolites, which change into different countries and continents of this globe. And what is more important, we have the microbes and the microbial toxins. And the microbes can be pathogens, you all know them, Salmonella, E. coli, Clostridia. And we have the microbial toxins, and these include, of course, again, Clostridia, but particularly the topic of today is endotoxins, also called LPS, which are from gram-negative bacteria and which are normal present in the intestines of every animal. And we have the topic of mycotoxins, a little bit the focus of today. Now we'll start with the mycotoxins, because mycotoxins are true natural toxins produced by fungal species. You all know this. But to understand mycotoxins, we have to go also to the different production stages. And on the left-hand side, you see the so-called pre-harvest contamination. And pre-harvest contamination means that the fungi invade the living plant. We call this also pre-harvest contamination. Particularly, we have the Fusarium species, a broad variety of Fusarium species that can produce a number of toxins. And the toxin production is mainly influenced by climate and the environment. Good agricultural practice is here the key word to be mentioned. That means soil management, that means also fertilization of the soil, that influences the degree of contamination at the pre-harvest stage. The plant has a kind of an interaction with the fungi, and this will lead to complex molecules, the so-called modified mycotoxins. I will explain this in a minute. And this depends very much on the plant variety you are using for producing your crops. On the right-hand side, you see what is in principle perhaps the most important way of contamination in your own country, and that is post-harvest contamination. These are Aspergilla, Penicillium species, but also Alternaria, the black molds. And these combination of molds in a silo or in a storage facility results into co-exposure of the animal to multiple toxins, because in one silo can be a real family of toxins. And this depends on the storage conditions, particular moisture and temperature. You all know the different publications on this area where you really can look into water activity and temperature and the impact on mold growth. If we go to the next slide, and this is what I mentioned before, we will discuss briefly the masked mycotoxins because it's an invisible risk. Masked mycotoxins have been detected first in 2014, 2015, and this concerns particularly Fusarium toxin. Masked mycin means that a toxin like DON, here used as an example, is conjugated by the plants to another molecule, very often glucose, but also methionine or glutathione can be conjugates here. This happens in the living plants and only in the living plants. And these mycotoxins are excreted by fungi to the plant tissue and considered as toxic for the plant cell. Now, the reaction of the plant cell is this conjugation, also called modification of mycotoxins as a protective mechanism. So the conjugation to glucose. What we result in is that the modified mycotoxins are not detected by common analytical methods. Due to this conjugation with glucose or other molecules, the physical-chemical property of the mycotoxin changes considerably. And this is why we do not detect them routinely. We can detect them by modern methods, requiring a pre-clean up step with a fermentation process. And the same fermentation occurs in the intestines of an animal because the modified mycotoxins can be liberated in the gut, in the intestines during passage to the small intestines and large intestines, and in this way contribute to the total animal burden. And if I just use again DON as an example, because this was a model compound where this process was studied, we can say that 50% of the DON is bound to glucose molecules, can be 1 or 2 or 3, and therefore are not detected by routine methods. So this is why we call these masked mycotoxins or the invisible risk, because we very often neglect them and have to consider them when we later on discuss the impact on animal health. Now, just a quick summary on mycotoxins are the secondary metabolites of fungal species. They are produced under conditions of stress for the fungi, and they can be produced pre-harvest and post-harvest, as I just mentioned before. And we have to explain to our customers that mycotoxins are not living organisms. They are chemical substances. They are very diverse in structure. So there is not one mycotoxin theory. There is simply, we have to address them one by one or class by class. Mycotoxins, per definition, are toxic to all animal species, but they have very typical species-specific biological effects, depending on the diverse structure. And they are non-immunogenic. That means an animal cannot develop a tolerance by making antibodies or whatever to the mycotoxin. Another important aspect is for the feed millers, they are heat stable, so we have a minimal degradation during processing, like extrusion or pelleting. They are acid stable. Customers very often think they are like salmonella. You can combat mycotoxins by adding acids to the drinking water. So drinking water acidification has no effect. They can be degraded by UV light and ozone, most of the mycotoxins at least. And UV light drying crops in thin layers outside or on the roofs is a very simple and easy method to reduce mycotoxin burden, as is the same that you can clean and de-dust your commodities to reduce mycotoxins. These simple methods should be having more emphasis in daily life because they do not cost anything in principle, but of course they are labor intensive and cannot be done in all operations. And the last point to mention here on the mycotoxin area is that mycotoxins can be degraded by enzymes. And this is what we use now also in the future in feed technology. By adding probiotics or initiating fermentation process, you can reduce the mycotoxin burden and the contamination of feed materials. Now, the history of mycotoxin research began, of course, in principle in the 1960s in Europe, when aflatoxin was imported with groundnuts to the UK, to Great Britain. And there the analytical procedures for the first time started, with the simple TLC method where you can see the fluorescence of the different mycotoxins, particularly aflatoxin, B1, B2, G1, G2. This was really the starting point. The problem is still present in the entire world. Even if we can measure this, we see that the economic losses only in the US are more than $5 billion per year. They made an economic balance. And we have a lot of concerns, particularly about aflatoxins, because aflatoxins have been identified as carcinogenic compounds in the food chain. I will not go into all the details here, but what we have to take from this slide as a message is that food from animal origin, and then I'm talking about milk, meat, and eggs, contribute only to less than 10% of human exposure. The direct consumption of nuts or groundnuts is more than 90% of human exposure. The residues of aflatoxins or other compounds in meat, milk, and eggs contribute only to a minor extent. I will come to that back when we discuss individual mycotoxins. Now, looking into the effects of adverse effects on the animal, the target sites and clinical relevant endpoints of toxicity, we're starting with aflatoxin. Of course, the liver was identified first. And I will show you now a short series of slides with these endpoints of toxicity, which was organ-specific, for example, the liver. And we see here the mycotoxins known to affect the liver being hepatotoxic. These are the aflatoxins with biotic proliferation, fatty liver syndrome, the ochratoxins, the fumonisins, and the trichoticins. We could explain this in all detail because the liver, of course, is the impaired, is the main organ for a synthetic capacity. So they can produce, in principle, all molecules needed by the body, and this automatically means that we have impaired weight gain, that we have poor utilization, is the liver not functioning, egg production is dropping, and we have a poor immune response because the immune globulins, one of the biggest defense mechanisms of the body, are also produced by the liver. So the liver is a central organ that is very, very important for animal health. And if the liver function is impaired, and that can be by lipid peroxidation, by oxidative stress, there are various mechanisms, but if the liver is impaired, the animal will not function properly and even might die. The second point is the kidney. It's also an endpoint of toxicity for a number of toxins. The most prominent nephrotoxin is Ochratoxin A, which you see here some slides about the tubular necrosis. We do have in cardiomegaly as typical signs of ochratoxin. You see here also a little bit of bleeding, discoloration of the kidneys when you look into postmortem in the carcass. And we know that the major toxin is ochratoxin, citrulline, but also penicillic acid, fusarium. Various fusarium toxins have a negative effect on renal function. What you see in the operation is increased water consumption. We have wet litter, which is of course non-desirable. We have energy losses, and we have a poor feed conversion rate. And finally, again, impaired growth rate that will affect the profitability of your business. The third side I want to mention as a side of an endpoint of toxicity is muscle tissue. It is very often the forgotten endpoint because it seems that the animal is not suffering very much from this damage. Ochratoxins, cyclopyrazonic acid, fumonisins, and trichoticins can all result in poor meat quality, peel, soft, and exudative meats, and hemorrhages, particularly in the breast, and also the so-called wooden breast, so poor quality. And some of these compounds, like Ochratoxin A and CPA, might even result in undesirable residues in muscle tissue. The main mechanisms behind this is an impairment of calcium metabolism and poor bone strength, as well as bleeding and hemorrhages, and reduced blood supply, giving you this poor quality of the muscle. Finally, I would like to address the reproductive systems and link to the next generation. Poor eggshell quality, impaired calcium metabolism is a typical sign of many mycotoxins. Of course, this results in poor hatchability and a high embryo mortality. Mechanisms behind, we could discuss in all detail, are oxidative stress, and particularly also the impaired immune competence of the young chickens. And this is something, impaired immune competence, and this is a subject I would like to focus now in detail. There are numerous publications from the very beginning focusing on the impact of mycotoxins on the immune system of animals. In early days, we used a kind of assays like the lymphocyte transformation assay to show this. But we didn't know the mechanisms really behind. It was a descriptive measure. And only recently, we understood more that the main side, and therefore the fifth side of toxicity, is the tight junction complex of the intestinal barrier. And these investigations are mainly done in the last 5 years and will certainly continue. Now, this is a complex matter because you have to understand how the intestines function on a molecular level. In the intestines, the most important part for us is the nutrient transport. But the nutrient transport is carrier mediated. We have carriers for glucose, we have carriers for amino acids, we have carriers for fat molecules. So this is a very controlled process happening in the intestines, where we have on the upper level here, where here comes a digester, so the food or feed, and then these processes allow that they are transported. Now this transport goes from the apical side, that means the side where the nutrients arrive, so where the digester arrives, the feed, that goes in principle goes directly through the cell and can go in both directions. Some certain ions can be exchanged, and sometimes there are also a kind of a bypass. But in principle, this is a transcellular pathway across the cell membranes of these epithelial lining cells. Now, as the apical site, as we have here the feet by definition is not sterile. And here are also the microbiota of the animals, which are, of course, very, very important for the digestion, for the fermentation of feed materials. So what the body has to do is to establish an intestinal barrier. And the intestinal barrier is formed again by these epithelial cells, but as a secondary measure, they produce tight junctions. And these tight junctions are specialized molecules that really close the space between the cells. And the tight junctions are a very, very complex network in the cell, like a spider web, making sure that these are absolutely functioning, that they are produced in the cell, and that they can be here as a kind of a blockade between the different cell types. Now, this would mean that if the tight junctions are affected by a compound, and this is what mycotoxins do, they interfere with the spider web, the formation and the transport to the cell membranes, and this is what we call leaky gut. Because suddenly, when the tight junctions are not functioning, we allow a paracellular pathway across the tight junctions, so across the intestinal barrier. And this is the first target for mycotoxins after oral ingestion. Most of the mycotoxins can disrupt these tight junctions and allow a paracellular transport of antigens and pathogens. And this is something we only recently understood. And this is why we are focusing so much on it. Here you have another slide trying to explain the intestinal integrity and also the immune components, because now we understand this is again the epithelial cell layer you have on top. And what you see here in the scheme is all the immune cells which are in the intestines, and the intestinal tissue harbors more than 60 to 7% of the immune content. And this explains why this part is so very, very important. We have the dendritic cells, we have the lymph cells, we have the plasma cells, and all other immune cells are in very high concentration in the intestine. You know this from histology, from your basic training in animal physiology. If this system is impaired, we will have a higher vulnerability to infectious diseases, and even the outcome of vaccination programs are impaired in all animal species, because also the antibody-producing cells are affected. And now with a click, I show you the mycotoxins that have been investigated to affect these, and these are particular DUN and nivalenones of fusarium toxins, but also aflatoxins, ochratoxins, fumonisins, patchouli, the eniatines, or even the minor toxins affect these intestinal barrier. And the intestinal barrier and the tight junctions is so important for the integrity of the animal. And you see also that the mucus layer, which is the next protection line, is affected by Dolm T2 toxin, zearalenone, patchouli, and many others more. The lymph nodes in the intestines are directly controlled by aflatoxins, ochratoxin, T2 toxin, and other fusarium toxins. And we have oxidative stress that is exerted by all toxins, and the entire system is deranged. And this makes them vulnerable to infectious diseases. Now, the leaky gut, as it is called, the tight junctions are not functioning, allows the transepithelial transfer of salmonella, for example, because everybody was interested, of course, in salmonella because it's an important subject in poultry business. And this I cited from a publication that was already produced in 2011, where the first time they measured the passage of Salmonella typhimurium in an affected barrier, where DUN was used as a model compound. And you see here on the right-hand side, you see it looks a very small increase in Salmonella passage, but don't forget that it's a log scale. And if you see the real biological consequences, you have to look into this slide, because this is the inflammatory response. The inflammatory response can be measured by measuring the cytokines like interleukin-1 beta or interleukin-6, which is a chronic one, and you see that they go dramatically up. And this has been done as a model experiment with Salmonella typhimurium, but also with coccidia, because leaky gut increased lesion scores and thereby also shedding of coccidia. And you see here again the model compounds DOA and fumonisin and the combination thereof. And you see that the lesion scores dramatically goes up. And this is something that really affects animal health. You see the very poor animals. These were model infections we did with Maria Brunetti in the presence of DOA. So this is really one of the crucial points that we learned in the last few years, because these lesions to the intestines occur already at low concentration. Globally, the awareness of mycotoxin has been increasing in the last years. And people said, yes, you can avoid very high concentration, but you have to be aware of the fact that even at low concentrations, these processes in the intestine are starting. Now, this brings me also to a last effect in leaky gut system, because leaky gut enables also the passage of bacterial endotoxins. And this is a link between exposure to mycotoxins and also to normal bacterial flora in the intestine. In all intestines, you have gram-negative bacteria. This is normal. That is physiologically. And these bacteria have in their outer membrane, they have a compound called endotoxin, or LPS, lipopolysaccharide, because it's a lipopolysaccharide structure. And they are in all gram-negative bacteria. These compounds induce an inflammatory response when they go into the body. And like the mycotoxins I showed you before, and the salmonella I showed you before, they induce TNF-alpha, IL-1, IL-6. They induce fever in the animal at higher concentration, and particularly reduced intake that is linked to IL-6 production. And they stimulate a lot of negative metabolic effects. Now, endotoxin is a very large molecule, you see it here, and stays normally in the intestinal lumen. So that would not be a real problem for the animal. Therefore, you have the intestinal barrier. But if the barrier is affected, endotoxin will enter the body and will cause this inflammatory response. So getting a little bit towards a summary, we have to understand mycotoxins, and we have to understand what has changed in the recent years due to the more insights we have in the mechanisms of action. When we look now into toxicological endpoints of concern occurring at low concentration of mycotoxins, we focus on gut health and immunity, as these are already impaired at low concentration. We find an outcome is reduced feed utilization, reduced weight gain, metabolic effects, immunological effects, so the non-competence and this vulnerability to infectious diseases, and also reproductive effects due to chronic inflammation. So from the old textbook where you saw these pictures of T2 toxin, we now go into hardly visible mold contamination and low exposure rates. So we changed from clinical visible intoxications to health risk affecting productivity and profitability as a major concern, mycotoxins together with bacterial toxins. The vulnerability of the animal is not only concentration dependent, so the amount of mycotoxin, but also we have to look into what really happens to the animal, real life scenarios. You know, I've been trained in risk assessment for many years, and risk assessment now focuses very much on these real life scenarios. And one of the most important cofactors affecting the vulnerability of animals is heat stress. Because heat stress is, and these are model experiments we conducted in my institute, heat stress is also affecting these intestinal barriers. To summarize, is we have to face multi-mycotoxin exposure. This is what we discussed in the very beginning, that we have pre-harvest and post-harvest contamination. We have, of course, the vulnerability according to age, with its incomplete intestinal barrier at a very, very young age, and the immune competence develops only after hatching fully. We have the production states and breaches of stability, and we have stressors. And this is in principle the point we are focusing on: heat stress, leaky gut, intestinal infections, and duration and exposure of multi-mycotoxins and LPS. And of course, this results in an increased prevalence of infectious diseases and an imbalance of the microbiota, and that directly affects the productivity of the animal. The final thing I want to address very briefly is the common intervention strategies, because you can read and very much about on the internet on mycotoxin binders. In principle, the word binder is not entirely correct. We better should talk about mycotoxin mitigating compounds. The most prominent class are the mineral clays, which the first one, which was the sodium potassium silicates that had been developed already in the 90s to combat the aflatoxin stress. The phytosilicates, and you have the well-known examples like bentonites, mectonites, montmorilites, clinophthalate, and so on. They have been developed to absorb mycotoxins, particularly aflatoxin, and they now regain in importance because we find them that most of those compounds also can bind LPS, and this is an asset we should use in daily practice. We have the organic polymers, particularly derived from yeast cell walls, the 1,3-beta-D-glucanes, and we have also humic acid compounds which are only regionally used. These compounds from yeast cell walls are very, very important to add to the mechanism of binding, because they can absorb ochratoxins, zearalenone, T2 toxin, ergovalin, and many others that are a little bit poorly bound by the mineral clays. And we have, of course, the live yeast products. There are numerous strains available, and they are used very nicely, the lactobacilli and also live yeast products, to absorb mycotoxins in the intestinal tract. At the same time, they are gut health stabilizers, who have a very positive effect on the microbiome, and therefore also used as probiotics. What I should mention is also the phytochemicals, because phytochemicals really look into the mechanism of action of certain toxins, and perhaps the most prominent one is silymarin, because it has a strong hepatoprotective effect. And we all discussed in the beginning, and still as the most important mycotoxin, aflatoxin B1, with the liver as a major point, and there you really have a benefit if you add silymarin to your product. Well, we also have to consider that there are mixture and blends of all different individual classes in the market. They can have additive and synergistic effect. And we look into multi-mycotoxins effect and also endotoxin binding. So these are the parameters you should check the product you are using. So I would like to close with some take-home messages. Mycotoxin contamination of common feed materials, cereals and grains, is a global problem. And at the moment, there are no evidence that we decrease mycotoxin combination. It is still on the increase at the global level. Mycotoxin contamination is increasing, as I mentioned before, and very much related to good agricultural practice, like minimum tillage, plant genetics. Soil destruction is a big issue. And my university, my colleagues from plant sciences are working very much on the plant microbiome to make plants more resistant to fungal invasion, and of course the climate change. What you can do is to improve your storage conditions, and you have to consider that you have a sufficient feed preservation, and that many of the propionic acids which are used here have a certain shelf life, so they are unstable if you have to have a longer storage period. Second part of my take-home message is there is an increasing awareness that had in principle reduced in the last few years the incidence of acute clinical outbreaks of mycotoxins. But the adverse effect in poultry operations are predominantly the economic effects like reduced weight gain, reduced feed utilization, and poor immune competence. And these are very much linked to what I mentioned, the damage on the intestinal tract and the intestinal barrier integrity, to direct effect on the tight junction. Mycotoxins affect the intestinal barrier and boosting the pro-inflammatory response of bacterial endotoxins. The combinations of mycotoxins and endotoxins at the site of the tight junctions is a real detrimental factor. In risk management, we have to use competent mixtures of mycotoxins and LPS mitigating substances as a routine measure to improve our profitability of the business. And with this, I want to close. Again, you have some pictures of my university. You're welcome to Utrecht, and always remember, an ounce of prevention is a pound of cure. Thank you so much for listening.
Johanna, thanks a lot for this journey through this very complex topic. We know normally we cannot have a 30 minutes presentation to cover this all. We want to have this presentation as a platform to start a discussion. This is I think the most important part here. So everybody is welcome to enter his questions. I see already questions coming in, and meanwhile Claudio and I guess Dr. Mahendra meanwhile replied some of the questions. Johanna, please have a look also to the questions which have been raised during your talk. Some very, very interesting questions. I see participants are listening, digesting already, getting questions and showing these. Again, now we will have the questions being answered real time. Afterwards, after the presentation of Claudio, we will have a discussion session where we answer the more complex questions verbally, and the ones which we will not be able to answer due to time, we will send later on to you via email. Now it's the time to have the third presentation. We are very much in time. Dr. Claudio Campanelli is our employee from EW Nutrition. I'm happy to have him here now to give the last speech. He studied at the University of Milan in Italy and graduated as PhD on the evaluation of the composition of goat milk fed with fatty acids esterified with calcium. Very complex. Subsequently, he worked as a technician on dairy cattle and later as a technician on dairy cows. Following this experience, he worked as a technical sales manager in the enzyme business, and since 2014, we are happy to have Claudio here at EW Nutrition, having worked in different positions and now being the regional technical manager for Europe. Claudio, this is your stage.
Thank you, Klaas. Yes, we can start with the presentation. Thank you very much for all attendees to dedicate the time to our webinar. And first of all, I would like to speak today about what is the concept of risk evaluation. Risk evaluation, how can we interpret the risk of the contamination of mycotoxins, but also bacteria toxins. Have you seen how Johanna Fink-Gremmels in her fantastic presentation showed how it is important to understand the activity of lipopolysaccharides and the toxins in the intestinal gut, in the intestine of our animals. Is direct correlated to the performance, is direct correlated to the health of the animal. So it's very difficult to understand what is the level of, and the quantity of lipopolysaccharides we have in the intestine of animals, of course, but it's quite relatively easy to understand what can be the contamination of mycotoxins in our raw material. Therefore, it's important to understand how is accurate our interpretation of the risk, our evaluation of the risk. So we put the extreme attention for sampling and analysis, for example, and we have a high level of, let's say, data interpretation from the analysis coming back from the laboratory, coming back from the field. Or maybe we are just sampling fastly the raw materials and with not particular accurate in the analysis, maybe just one single repetition, or maybe we don't have any follow-up in considering the data coming from the laboratory. Or worst, we analyze rarely the raw material, so maybe we don't take in consideration a large spectrum of mycotoxins, but just few of them. Or maybe we don't analyze the raw material at all, and we think that our mycotoxins is not a problem of ours. There are different situations in different areas and a different approach that we can have in terms of mycotoxin contamination. But what is the risk evaluation? In the end, the risk evaluation passing through just one second, I put laser point, yeah, pass through, let's say, identifying the risk. That's clear. It is the best and the most important thing that we can do. Identify the risk, what does it mean? It means, first of all, to understand really what can be the risk in terms of number and in terms of contamination, in terms of concentration of mycotoxin present in raw material. But firstly, before making any analysis, the most important thing is the sampling. To make and to have an accurate data from the analysis, pass through to have a right sampling procedure, because the sampling can interfere to the analysis until 70% of the reliability of our data that we can get in the laboratory. Therefore, it is very important to follow a right procedure in sampling raw materials or feed or complementary feed or whatever. Therefore, as soon as I have and I follow my right procedure in sampling, of course, we have to analyze the raw materials or feed. And to analyze the raw material, it is not important the method that we use. We can use an HPLC, we can use a lateral flow device, you can use ELISA. It's not important, but the most important thing is that the data has to be absolutely statistically reliable. Therefore, the analysis has to be, as much as possible, accurate. Then, this is, in my opinion, the most important part, understanding the risk. Understanding the risk, what does it mean? It means interpretate exactly what these numbers are coming from laboratory. Johanna Fink-Gremmels spoke, for example, very deeply about the conjugated forms of some mycotoxin. The oxynivalenol is one of them, but not only the oxynivalenol, a different kind of mycotoxin can be conjugated with sugars, with monosaccharides, disaccharides, and with proteins sometimes. Therefore, we have a screen of mycotoxin and we have a level of contamination that we normally don't see, because normally we don't analyze. To analyze the conjugated form of mycotoxins, we have to do absolutely a particular analysis, and we have to do a particular research of them. But not only mycotoxin, not only conjugated form, of course, there is also to take in consideration, we have to also take in consideration the synergistic effect between different mycotoxins, and also between mycotoxin and endotoxin or azotoxins, for example, from gram-positive bacteria. In any case, understanding the risk, it means to interpret in the right value, in the right way, the data that coming from my analysis. After to evaluate exactly the risk, we can propose the solutions, of course. Therefore, we have to understand what is the problems of the farmer, of the client, in order to identify the risk, understanding the risk, and proposing the solution. Because only if we know the problem, we can propose the solution of the problem. I would like to show you what can be the contamination in the area of Bangladesh from January to May, and why we can have this data. We have this data because we collect the data coming from the field and from the risk evaluation that we saw before, coming from the samples that we collected and we analyze, in order to have our own database of contamination area by area, or or mycotoxin by mycotoxin, in case we can elaborate as we want. But in this case, it's important to understand that from January to May, for example, I took in consideration aflatoxin, ochra, and deoxynivalenol. And you can see the average level of aflatoxin in India and Bangladesh from January to May is anyway higher than what we consider the threshold for poultry. We consider threshold for poultry as a 10 ppb, this is expressed in ppb, of aflatoxin. Of course, these numbers are relative. I mean, because there is not, they say, okay, we have 11 ppb, so we are over the threshold. We have 9 ppb, we are under the threshold. It's not so rigid, of course, because we have to take in consideration also the possible interaction and synergistic effect of aflatoxin with other mycotoxins. But in any case, and we know that we don't have always one mycotoxin present in the feed, but unfortunately we have always a cocktail of mycotoxins, different mycotoxins. But it's important to understand that anyway, as an average, considering the 166 samples, and considering that of these 166 samples, 155 were positive to aflatoxin, the average level of in ppb of aflatoxin in the samples collected in Bangladesh and India were quite high. Also, with peak of 150 ppb of aflatoxin is a really high level of contamination. But also ochratoxin, we are very close to what we consider the threshold of poultry for ochratoxin, but the discussion is the same. Don't consider this number as a rigid situation, but we have to take in consideration all possibilities that we have in terms of especially subclinical symptoms. Different is, for example, I also wanted to put an example, the deoxynivalenol, because poultry are absolutely less sensitive to the deoxynivalenol in comparison to swine, for example. Therefore, okay, deoxynivalenol in Bangladesh and India, honestly, we don't have problems from January to May. Then I hope we continue not to have problems. Let's see in the rest of the year. This is practically reflects more or less what we had in terms of database with in the same area, India and Bangladesh, for example, from July to December 2019. Also here, in July, December 2018, in terms of aflatoxin, we had India, Bangladesh, an average level of 48 ppb of contamination, and 48 as average in samples. I consider a little bit too high, honestly. Also, the peak was very, very close, 150. In ochratoxin, okay, we had less problems, and so the average was 10. But in any case, we can take in consideration that also between ochra and afla there is a synergistic effect. In any case, this is just to understand what we do when we collect the data. The risk evaluation is important because to interpret the risk, that's clear. That's the most important thing. We want to create a solution. We want to give a solution in terms of contamination. Therefore, to give a solution, we need to understand really well how is the contamination and what this contamination can influence on the performance of our animals, firstly. But secondly, also because to have a clear idea of the contamination in the area that I'm operating as a farmer can be also important, because also for our technicians it's important to suggest the right product and the right dosage in consideration that in this particular area, in this particular part of the year, point of the year, there is a particular contamination. Therefore, aflatoxin is still the main problem in India and Bangladesh. It's confirmed since the data collected in July, December, and is confirmed, unfortunately, this year from January to May. Therefore, the solution can be, of course, products with the right dosage and the right product of the line of mycotoxin binders that in case of EW nutrition is called Mastersorb. Why is it important to have particular products containing particular ingredients? Because, as we know, in the end, we want to meet the expectation of the clients. Therefore, we want to solve absolutely and totally the problem of mycotoxin contamination. We want our client can manage, therefore, the performance using the raw materials. And we say, normally we used to saying here, sleeping well, because we want our client to use the raw material and the most interesting maybe raw material in the market in terms of commercial opportunities or in terms of availability also about raw materials. And of course, it's important to choose the right raw materials in terms of quality, but in the same time, sometimes the feed producer has to use particular raw materials, which maybe is not the best. But the mycotoxin binder must be solved, must solve absolutely the issues that this kind of raw material can give. And of course, protect your brand, because every feed producer who produce a feed want to put in the market a clean feed and a feed without any problem, without any issues further after the selling in the animal performance. Therefore, in the end, what is very, very important, and Johanna Fink-Gremmels explained very well in her presentation, the intestinal integrity. The intestinal integrity of our animals are the most important things. Therefore, okay, we can speak about the oxynivalenol, we can speak about endotoxin, we can speak about the binders, we can enter in technical details, but in the end, what is important for us is to have and to maintain the performance of animal and to have a return of investment in investing money for a toxin binder. And this return of investment is important and is measurable by the performance of animals. This is also a very important point, because EW nutrition is able to demonstrate every time how can be the return of investment in using mycotoxin binder, following our toxic risk management programs, honestly, because of course we are not speaking about only breeders, but we can speak about only about broilers. Therefore, risk evaluation, risk interpretation, solution that we want to propose to the client, and in the same time we want to create a sort of, let's say, cooperation, and in order to collect as much as possible data and to give as much as possible solution and monitoring constantly the feed and the raw material of our clients. This is our approach, and the approach that we want to keep and to maintain with the clients too. Because in the end, already Johanna Fink-Gremmels explained very well, we have to take in consideration different things. I repeat, interaction between mycotoxin and gram-negative bacteria in terms of endotoxin, in terms of release of lipopolysaccharide. In this case, in this trial, for example, it's very clear, no? We can measure an inflammatory cytokine like interleukin 1 beta or interleukin 6, and you can see that with a challenge of 1 microgram per milliliter of deoxynivalenol, the level of interleukin produced by the animal is certain particular level, which is higher if we see the Salmonella typhimurium challenge in the group, and higher again when with the Salmonella typhimurium we add, for example, the oxynivalenol. The oxynivalenol and the lipopolysaccharides from this bacteria, which is a gram-negative bacteria, of course, is very important. The activity, the interaction activity is very important. Also with a gram-positive, we have the same situation, because in this trial where count the number of animals with enteritis lesions, necrotic enteritis lesions in the intestine by Clostridium perfringens. But you can see how also the group with Clostridium perfringens plus Trichothecene, like the oxynivalenol, the number of enteritis lesions were higher. That's also to demonstrate that there is also an interaction between the oxynivalenol and also with probably alpha azotoxin. In this case, we are speaking about azotoxin because we are speaking about a gram-positive bacteria, Clostridium, but also with alpha azotoxin, the oxynivalenol can have a synergistic activity. Therefore, it is absolutely important for the solution to have a product which is able to bind lipopolysaccharides as well, for example, endotoxin, and also trichothecenes. In this trial, for example, this scientific validation trial made in Utrecht University in Netherlands, we tested the different binders, including Masters of Gold, with different, with other three important products in the market as important brands, the most important brands in the market, we can say, in terms of binding capacity of lipopolysaccharide, using a particular concentration of 0.5 nanogram per milliliter, sorry, 50 nanogram, because I'm speaking nanogram, 50 nanogram per milliliter of concentration of lipopolysaccharides, and in the two solution, in one of the two solutions, we added the binders with 0.25% of inclusion and 1% of inclusion. But you can see, for example, in a particular condition of temperature, time, etc., Masters of Gold behaved in a different way in comparison to the, let's say, the most important, I repeat, brand present in the market in terms of mycotoxin binder. Therefore, it's important to have a product who is able to bind the lipopolysaccharides, because, I repeat, it's very difficult to understand what can be the endotoxemia in an animal. We should take a sample of blood, analyze the blood, or analyze some biomarkers from the blood, like interleukin 1, interleukin 8, different inflammatory cytokines, or a different situation. But in the end, or in necroscopy, we can consider the enteritis, intestinal lesions, or the activity, the tight junction, eventually, if I can do a deeper analysis of the intestine. But it's very difficult in vivo to understand what can be the level and the number and the concentration of lipopolysaccharides in the lumen of intestine. But it's important to understand that we have a product that is working anyway as much as possible against the lipopolysaccharides. In this case, we made a nice trial demonstrating that Masters of Gold is able to bind the lipopolysaccharides, and we made a very similar trial that we made in Utrecht University. We made the same trial in Crea in Rome, in Italy, where we measured in vitro the level of interleukin 8 produced by a tissue of intestinal tissue from a pig, in order to understand what can could be the impact of the certain level or certain concentration in the solution where we start of lipopolysaccharide without and with the incubation with masters of gold. Therefore, it's clear that interleukin 8 was less in the solution treated with masters of gold, probably because there was less also the level of lipopolysaccharides which attached the cells of this intestinal tissue, because most of them were bound by master sorb. And this is confirmed by a picture with in this case, where we can find the nuclear factor phosphorylated bound colorant, red phenol, and you can see how in the group treated with endotoxin, the nuclear factor, which is an activator of interleukin 8, in this case, is really more visible because bound to the colorant in comparison to the group treated with masters of gold. But in the same time, we need to have also a binding capacity of against trichotechanes, DON, T2, and ZEA. That's also very important. And also in this in vitro trial made in Trilogy in the United States, we can show how, if taking as a 100 the binding capacity of master sorb against the deoxynivalenol, for example, the most important also brand present in the market, the binding capacity was absolutely lower. That's because we took in consideration the behavior of the pH of stomach and intestine, in the same time also the time, because the deoxynivalenol is absorbed in the first part of intestine in poultry in maximum 10 minutes, 5-10 minutes. Therefore, the bioactivity, for example, of some competitors is not able to degrade the deoxynivalenol in a short time. Therefore, to summarize, master sorb contains bentonite and E cell walls to bind efficiency bacteria, toxins, and of course all range of mycotoxins. But not only, master sorb contain also silimarin, which is very important in terms of antioxidant activity and in terms of stimulation of protein synthesis. We have, of course, from the point of view of quality, we control batch by batch in terms of quality. But the most important thing is that there is, against endotoxin, lipopolysaccharide, the activity of masters of gold is really unique in the market. But everything I said and everything we'll say normally are supported by scientific validation trial made in vitro and in vivo, made by scientific research center or universities. That's the most important thing. Okay, thank you very much for the attention. I apologize if I took too much time, but this session of question very important for question and answer. We are absolutely available for that. Thank you.
Thank you, Claudio. I know the challenge. You want to express your knowledge in mycotoxins and endotoxins and the solutions we have for the market from EW Nutrition. You were asked to do this in a couple of minutes. You managed very well. Maybe you extended 1 or 2 minutes, but it is a challenge to get everything very, very short. Now I would like to take the chance. I saw many questions coming into our inbox. Dr. Mahindra already started replying, Claudio replied, and some questions, Johanna, are for you, starting with Professor and so on, and you can see these in the question box. I would like to hand over.
I tried my best during the presentation of Claudio to answer as much questions.
Okay.
But Claudio, you were too short for me.
Yeah, very good. So, okay, I would now to
answer. We have to answer.
Yes. So maybe Claudio, can you go from the top I think it's the easiest to dedicate from your perspective who answers best the questions. And again, if we will not be able to answer them all, we will answer them personally
Yes.
afterwards via email.
Yes, these are the most are question for Johanna.
Shall we start with on top with the LPS measurement?
Yes, in the field we adjust the case was by mycotoxin. However, there are a secondary problem which look first, such as immunosuppressing outbreak. Yeah, okay. Otherwise, while we practice at farm, how manage our farm to decrease mycotoxin, but this is a really general.
Yeah, I think that's a nice one.
Yes, it's, and I hope and I think to have answered the mostly about this question with my presentation. Is important to have the right risk evaluation, the right risk interpretation, and to propose the solution, but a very precise solution. Therefore, there is no a solution in any case, but we have to take in consideration what is the contamination, what is also the species of animals, etc.
Perhaps I might add something, Claudia, because
yeah.
in certain areas of India and Bangladesh, you have also still poultry operations that produce their own feed materials, at least partly. And then you have to explain to people, if they are not buying formulated feed, that their first asset is to reduce mycotoxins, is to really look carefully into their own crops. And this is very often neglected. From my experience traveling in that country, I know that people use home, on-farm produced products, and it is very difficult to explain customers that their own product might be a risk for their animal health and welfare.
Yes, yes, thank you, Anna. And there is another question for you, for sure. How to assess the tight junction integrity? What are the parameters affecting tight junction integrity? You have already explained in your presentation mostly. But
you can measure it in two different ways. If you have to measure in the animal, we have certain markers you can measure in the living animal in blood samples, like the Z01, which is the zona occurrence 1 protein that can be measured even in blood levels. It is not very, very accurate in poultry. It works better in mammalian species, like in calves. There it works good, but somewhat poor in poultry. The other thing is you can measure, you can kill 1 or 2 animals out of the entire that are affected, and you can make immunohistochemical staining of the intestine, and this works perfect. We have specifically for poultry, we do have antibodies available, and you can use a staining method, which is can be done by every laboratory that is routinely using histochemistry methods.
Yes, thank you, Johan. There is also a question maybe I can answer. Which type of clay is best for mycotoxin binding? It's very, it's not easy to answer, because of course clay is a general term of hydroxy, sodium, calcium, aluminum, silicate, a lot of particular things. The clay is normally a natural, let's say, stuff coming with divided in different kind of chemical fraction. Therefore, also we can also understand what are the different fraction clay by clay, maybe making a particular X-ray fraction analysis. But the clay normally is composed by smectite, illite, montmorillonite, zeolite, depending on the kind of fraction that we are taking in consideration. Yes, we can define as bentonite, let's say, a group of these fraction clays which can be considered as the best in terms of bonding capacity. But also is very relative, because in the end the bonding capacity depending on other let's say the features of the clay itself. I can speak about the capacity of expanding the interlayer, of cation exchange capacity, etc. I don't want to enter in the chemical details now, of course, but there are different places in the market. The most important things, in my opinion, is to understand the activity and the binding capacity activity making in vitro trials binding capacity.
Yes, I very much want to focus on the last sentence, Claudio, because there are a lot of wonderful stories how to predict the binding capacity. And honestly, is the only real measure to prove the binding capacity is by measuring it. They're easy in vitro assays, and you just ask for the data. And if you go to European legislation, you will find that the testing of mycotoxin binding of mineral clays is written down in our feed laws, just because nobody can predict it really. Even with tickets and tetralayers and everything, you just have to measure. And then you know what's good.
Yes, thank you, Johanna. There is a question directly to you, Johanna. Dear Johanna, thank you so much for the very presentation, blah, blah, blah. And there are 3 recommended thresholds.
Is there a routine?
Sorry, because I don't have the glasses. Is there a routine method for measuring LPS? This is the first question. And the second is, are there recommended threshold level for LPS that can be used in the risk assessment?
The first question is rather easy to answer because LPS can be routinely measured by 2 different assays at the moment. One is a so-called LUL assay, which is a semi-biological assay with a little microorganism. A stimulus assay. Honestly, it is a very sensitive method if you apply that for feed, because feed components can interact with the assay and you need some experience. And on the other hand, we can measure LPS indirectly in the animal by measuring LPS binding protein. And you see now in many publications, we have experience with that also, that a lot of people change to measure LPS directly in the animal, because if it is in the bloodstream, it is detrimental. And if you can measure it in the bloodstream, you see that the binding protein, the LBP, the lipopolysaccharide binding protein, is increased. And this is an indirect measure for undesirable high exposure to LPS.
Yes, in any case, there is an official, let's say, threshold that we can say, this is the threshold for species for LPS, right, Johanna?
Yeah, no, that's right. But we have the normal levels for the LBP, for the binding protein.
Yeah.
There are normal levels published for poultry. I do not know the figure directly at the moment by heart, but these levels are published and you see an increase. And particularly when you do that in a laboratory, on a routine base, because that is quite a reliable assay that can be implemented as a routine method, but only in a specialized laboratory that is used to use biochemical and other blood analysis, then it can be very helpful. Because everything that is above normal, there is a background level, but very small. So everything, if this increases, you have a clear evidence of undesirable exposure to LPS.
Okay, thank you, Johanna. There is a question also, maybe I can answer, related to the product. Can mastazole gold bind the potassium and other nutrients? We do normally, usually, and constantly trials in vitro in terms of binding capacity relating to the vitamins and minerals that normally we have in feed and as considered as nutrients in order to understand and to maintain the level of binding capacity against these nutrients very, very low, practically very close to 0 and statistically 0. Therefore, we continue constantly monitoring the binding capacity of mastazole against every nutrient, which is, I repeat, 0.
Perhaps, Claudia, we have to add to this that this at the inclusion rate that is recommended, that is definitely 0. We have in high contamination rates of feed materials, people tend to use 5 or 10 times the recommended concentration. Yes, you can do this, but please then only for a short period.
Yeah, exactly.
There's also the same, and can mastazole gold bind Shiga toxins?
Yes. Shiga-toxin is a toxin produced by, as an enterotoxin produced by some bacteria. For example, Leusonia intracellularis produce a sort of Shiga-toxin, but we don't have any validation trial, we don't have any trial, and we don't have any evidence that master swab is able to bind this kind of toxin.
You have not tested it, but it's likely that it binds, because for other products, with Shiga-toxin, only very few tests have been done because the toxin is not easily available. But there is some evidence that bentonites bind Shiga-toxin as well. But this is something you would have to show for your own product, but it's very likely that it does bind.
Yeah. Explain the mechanism of prevention of endotoxin by beta-glucans. It's also a regeneration of epithelial barrier of intestine. We can say that endotoxin can be bound by beta-glucans probably, but the most important player in binding endotoxin for sure is clay and is bentonite. Endotoxin are bound by bentonite. And therefore, okay, it's important to have also a level of beta-glucans, especially in binding, for example, the deoxynivalenol. I explained before that beta-glucans are able in the helix to include maybe the deoxynivalenol, which is a quite big molecule. But in terms of endotoxin, I would say that the most important player is bentonite. Can you confirm, Johanna?
Yes, absolutely. What you have is a kind of a secondary effect of, because all the beta-glucans, so the yeast cell products, do not really bind endotoxins. Yeah. They have on the animal, they have a minor positive effect on gut health in general. That means a reducing of endotoxin produced in the intestine, so it's an indirect effect. But in terms of binding, it's really the bentonite.
Yeah. Yes, then of course the prebiotic activity of beta-glucans are important, that's clear, but in terms of binding, yes, absolutely. In the area with high humidity and temperature that mycotoxin presence is probably in a high level, do you recommend to formulate birds' diet with higher nutrient density? I leave this question to you, Johanna.
With higher nutrient density?
Yeah.
In principle, not.
Okay.
We have to accept that if you have really extreme temperature and humidity in a certain area, you have to increase the production time of broilers. Higher nutrients very often have a detrimental effect on the intestinal health. And as we mentioned before, heat stress is a very, very complicating factor, and heat stress and mycotoxins together are really detrimental. Now, what you have to look at, we know that you have a number of amino acids like L-arginine that can help you in maintaining tight junctions integrity under conditions of heat stress. That is L-arginine and also glutamine. So you have to perhaps recalculate your diet, but I wouldn't simply increase nutrient density. I would more to look into other amino acids that are very, very important in terms of gut integrity. This might be a better effect in the animal at the long term.
Okay, having a look to the watch. Meanwhile, we are with 90 minutes, and I still see number of questions increasing, questions coming in. So it seems we have raised the right topic. I would like to take the chance now to go to questions which are specifically dedicated to you, Johanna, because the other ones we can take and answer later on. But having you here, I would like to use the platform. So there's one question to Johanna. Wet litter is the major problem in broiler breeders in deep litter system in Nepal. How can we mitigate it? Very, very broad question.
Very broad question, very difficult question. The only thing I can tell you is that mycotoxins promote wet litter. That is definitely true. That has been demonstrated several times. But how to get rid of it is managing mycotoxins. That is the only answer I can give. So in managing, using a mycotoxin binder, you will reduce the problem a little bit, but not a little bit, but you reduce the problem considerably. But you cannot avoid 100%. If you have a deep litter, you will have it, and with your high humidity, you might be unable to solve the problem 100%. But just try. Mycotoxin management is one of the keys to manage wet litter problems.
There is another question for you. There are some animals, particularly pigs, that are comparatively resistant to mycotoxins. What makes them resistant? What do they have unique and the other species like in them? I wouldn't say that pigs are particularly resistant to mycotoxins, but Johanna.
Yeah. No, that's the first answer. Let's not talk about pigs because they are not resistant. They are sensitive, even wild pigs. But let's go to another species, and these are horses. Horses are really resistant to mycotoxins, to many of them. So all the ones we discussed, horse are the least. If you compare horse and broiler, it's a different, that the horse is 10 times less sensitive than a broiler. The reason for this is very simple. Mycotoxins are substrate for so-called efflux transporters. And these efflux transporters are sitting in the intestine, and the intestine, they are like revolving doors. So if a molecule enters a cell, these efflux transporters pump it out immediately, and it cannot really reach the vulnerable structures of the cells, like the nucleus of the mitochondria. And strict herbivorous species, like a horse, and also like certain breeds of cattle, they are less sensitive due to these physiological features. They do have the high expression of these efflux transporters. And all mycotoxins, particularly also Ochratoxin A, but also DON, nivalenol, they are all substrate for these efflux transporters. So this helps the animals to be protected. And in chicken, as they are omnivorous species, so they can use plant proteins as well as animal proteins, that's why we give them fish meal and so on and so forth, they have a lesser expression of these efflux transporters by nature.
Yeah. Maybe we can mention also the ruminants. Also, rumen, of course, is a big filter and can destroy some mycotoxin, not all, that's clear, but some activity of degrading mycotoxin in the rumen exists.
Yeah. That is a mechanism. Degradation in the rumen depends really on the microflora in the rumen.
Yeah.
And so they can degrade a lot of mycotoxins successfully. As I mentioned already, one of the main features of mycotoxins, as they are natural compounds, nature has invented a method to destroy it. And the method invented by nature is fermentation, degradation by other microorganisms. That's why we use lactobacilli, that's why we use probiotics in the management of mycotoxins. And this is also why we did a lot of experience in the late 90s and early 2000s of this millennium in India with fermentation processes of stored materials, particularly maize. Yeah. And this works perfectly, but it is a laborious and quite expensive method, and this is why it is not so widely used. It was very successful in principle, but it turned out to be rather expensive, and this is why it was not widely accepted, and I fully understand this. But it shows you what nature would do with mycotoxins.
Perfect, thank you, Johanna. Do you want to?
Yes, I think now it's time to close because time is running and everybody is busy, I guess, and I still see some questions which are not answered. We will take care about these ones. We have identified the questions which must have been answered by Professor Fink-Gremmels, and I hope we catch them all. The other ones we will manage internally, and if we need some feedback also from Johanna, we can for sure get feedback from her also.
Well, I'm happy to answer.
Very good. Thank you. So now 2 things to close. First, it's my pleasure to have the vote of thanks. I am very impressed by the great presentations we heard today by Professor Johanna Fink-Gremmels and by Dr. Claudio Campanelli. Both have shown a comprehensive overview to this rather big and complex topic, during this webinar, being able to make it in a very short period of time. Having seen all these questions from you outside coming in, I see we have raised the right topic with a great audience, which is you. To everybody outside, I want to say thanks showing your interest and your participation. To our panelists, Professor Johanna Fink-Gremmels, Dr. Mahindra, and Dr. Campanelli, a special thanks for presenting and being here for answering all these valuable questions. And also I would like to say special thanks to our channel partners, Nature Care from Bangladesh, Kantipur from Nepal, and Vet Care from Sri Lanka. Everybody outside, out there, please stay healthy and take some minutes to answer our poll, which will be uploaded by now. And with these words, I close the session. Everybody have a great day. Stay healthy. Thanks a lot.
Thank you very much from my side too. Thank you for your time. Have a nice day. Thank you.